Hello and a very warm welcome to our Agentic Observability Summit. From wherever it is in the world you're watching, we're sure you'll enjoy today's insightful talks. But this isn't all we offer at AI Accelerator Institute. We also have a number of in-person summits happening too. So whether you want to join us in Los Angeles, Berlin, or Boston, we hope to see you in person soon. Lastly, want to learn more? Check out our AI Pro membership, which is jam-packed with cutting-edge AI resources for applied AI professionals aiming to practice and enhance coding skills consistently. We will be sharing the link throughout the day, or kindly ask our event producer for the full link.
Hello everyone, welcome to another session. We are about to talk about the hidden cost of AI, and we are joined, and our host for this is the VP of Platform at Barndoor AI, Neil Mansila. Hi Neil, could you please join me on stage?
Hey there, Martin Ryan. Nice to meet you and everybody here.
I'll just hand over to you and let you do your thing. Thank you.
Awesome. All right. Well, let's get started, everyone. Thanks for coming today. I hope that the content has been good for you in the past sessions. My name is Neil Mansila, and I am VP of Platform Strategy at Barndoor. If you're any of the customers that are on this call who said you'd be joining, you probably know me as the guy that runs MCP operations as well. So very nice to be here, and let's get started. So our agenda today, we're gonna meet our virtual friend Priya, go over some of the things around hidden AI costs, and then I'll talk about some strategies that you should apply to stay ahead of those, particularly if you're embracing agentic AI, like our friend here, Priya. So please meet Priya. She's not an engineer, but she works in customer success. And a couple of years ago, just like us, she started using AI the way most of us did, very casually, tending to AI like she's tending to her little potted plant, all by hand, using AI for basic questions and answers, kind of like one and done interactions and chat interfaces. She might maybe paste like rough drafts of a follow-up email to ask it to clean it up. She might maybe drop in a set of like messy call notes and ask it to summarize things, or so that she can actually send it to her manager. Every single action that Priya was doing with AI back then in 2024 was pretty synchronous. She typed something, waited a few seconds, she waited, answer came back, and she decided herself whether she was going to use it. Nothing happened that she didn't watch happen in front of her. At this stage of her engagement with AI, she's not really thinking about it strategically. It was just a tool on her desk or on her computer, like those succulents on her kitchen counter. She's planting one new seed, watching it, tending it by hand, similar to how we use AI chat apps. But by 2025, Priya's using AI pretty differently. It's not just one-off questions anymore. It's more like things like QBR preparation, renewal risk assessments, real deliverables that Priya's manager's manager could act on. To keep up with this, to make sure that she can work effectively with AI, she has connected her real work tools to AI, Salesforce, Slack, Confluence, maybe even her Zoom meeting transcripts. So AI could pull all those things in, pull that context in directly instead of her doing a whole lot of copying and pasting. And she didn't have to build any of this. The AI apps and the SaaS business apps that she uses, or her company uses, they made direct integrations and agentic automations and workflows possible with just a few clicks. And the tasks that she had worked on have changed too this year or last year. They were longer, multi-step, more complex, things running in the background tabs that she does other things. Along the way, she also upgraded to the $20 a month plan. It was an easy call, $20, easy peasy. It's nothing compared to all the time that she's saving using AI. So you look at her garden now, it's not just one seedling, but a whole wall of lovely plants tended by a small crew of little helpers. She's still directing every one of them, but there's simply more happening, more than just one person can watch at once. And if we fast forward to today, it's the middle of the night, Priya's asleep, her garden tends to itself now. Agents water and prune things automatically whenever it needs it. And at work, it's the same story. An agent pulls the latest account data, cross-references Salesforce, drafts account briefs, and renewal risk flags, the tedious work that would usually take up an entire or multiple afternoons. Her agents are now connected to nearly all of her work apps and data. So earlier this year, Priya and a few of her like AI forward coworkers got bumped up to the next subscription tier. And again, she didn't build any of this stuff from scratch. The frontier model companies and the SaaS platform supplied most of her agentic workflows and tools. If you ask her how good the output is, she'll tell you it's about 75% of the way there, still room for improvement, but she can't imagine going back to work the way that she used to work before all this innovation. Because everything is moving so fast, that nobody, including Priya, really has stopped to think about how all of this scales. Her team didn't choose which models run behind the scenes, and nobody's tracking how the MCP servers behind it keep evolving, more tools, more data access, more actions. The change velocity is astounding. It's sometimes exhilarating, but zooming out, it's also pretty scary. So if you look at the garden now, it's not just 4 or 5 helpers. There are dozens of these little agents running around, working on every shelf all night, completely unsupervised. And if you look closely at her desk, you'll see a blinking red alarm light. And Priya's not there to hear it because, every decision that's got her to this point of like awesome, agentic automation seemed reasonable on its own. What most people don't realize, though, is that nobody was really measuring any of it, monitoring things as they grew, like consumption and usage, and containing it before it could get out of control. And that's where we're going to pick up next. So that transition, that Priya experience should sound pretty familiar to most of us here. A couple years ago, where AI was mostly chat-based interactions, I mean, we still use it that way today, but that's what it was only a couple of years ago, to today, where we're moving into agentic AI. And this is where costs and scaling concerns get magnified. Prompts, tools, and the reasoning performed by agents and the underlying LLM can consume resources by orders of magnitude more than a simple chat conversation. So whether we were truly prepared for it or not, agentic AI has just kind of glided into how we use AI to get work done today. And like Priya, we're at the point where we cannot imagine going back to where things were before we had AI as a tool to help us get some stuff done. But the majority of companies out there, I'm guessing including yours, have little visibility into what their costs of AI will be a year from now, or in some cases, even just the next quarter, as you can see from this graph and that quote. So the model your agent uses is likely to be the biggest determining factor of how much AI spend will be in regards to that agent, which is why we're going to talk about that first. If you've ever felt like there seems to be like a brand new model being announced every week from the big frontier AI players, that's about right. Here's a snapshot of just like the last 2 years of frontier model releases from the big guys. Major releases seem to be just like months apart, and minor releases sometimes just weeks apart. The pricing on the latest and greatest state-of-the-art or SOTA models, they run fairly close to each other. It's kind of like gas station pricing. They kind of stay pretty close. Generally speaking, as newer models roll out, the previous version's prices will go down, with the exception of that one weird one at the bottom, Claude Opus 3, which is still the most expensive to use because it's enormous as well. It's so therefore it's really expensive to operate. So it's a gargantuan model. I don't know many people that actually still use that one though. The current generation of flagship models, Anthropic's Fable, Opus, Sonnet, and OpenAI's GPT 5.6 and 5.5, and its variants mostly sit somewhere between $3 in for per million tokens input, and then $10 out for on the output side. And that's a part most people already know. You might have seen some of the price sheets. And there's a lot of models, and they're not all priced the same. What most people don't think about is that every one of these providers also ships a second miniaturized lineup along their flagship models, these mini and micro variants. So, for example, GPT-5 has mini and nano versions. Claude has Haiku. Google has the Flashlight. And what are these things? They are truly miniaturized versions that are cheaper for the providers to run and thus less expensive for us to use. So one thing to be clear is that you don't want to make the mistake of being fooled by their names like Nano and Mini, or even their lower price tags, because or the lower version numbers for that matter. These smaller models are still very powerful and capable, and it really depends on the type of work that you're asking the model to do. So just a year ago, or in some cases months ago, the capability that you can get out of these mini or nano models was considered bleeding edge and state of the art. So in exchange for the big price savings, the big delta between mini and full-size models is around reasoning and thinking abilities. So this step, model selection, is the one that most folks, when it comes to agentic AI, may skip entirely. If it's not that we're wanting to choose to go with the most expensive model and the less pricey one, and regretting it only when the bill comes. It's often that we don't even make that decision. We just kind of go along with the default. So most of the time, we don't even realize that there was a choice at all. In fact, there are so many more choices and options to choose from. Coming to the spotlight recently, if you're kind of a data nerd, you probably have known that these things have existed for a while, but in the spotlight now are open weight models. And open weight, sometimes referred to as open source models, are those that are released by AI labs, made available for download for free and free to use. Historically, I used to look at open weight models as things that like hobbyists would use, or maybe if you had like some internal project and you had some hefty hardware, you might want to try and give it a shot. That's just not the case. These models are getting very, very big and very capable. The models in this open weights realm that are getting the most attention are from AI labs based in China, like DeepSeek, Moonshot, Qwen, Z.AI. There's a ton of buzz around these open weight models for a couple reasons. First, they're free. You just have to run them yourself, or find an LLM hosting provider that runs them. And when you do, you'll find that the pricing is a fraction of leading US models cost. The reason there's buzz about them is because of the concerns that both individuals and companies have when it comes to using these models as it relates to the safety of their data, like fear that maybe their data is being trained on, or it's being exported or stolen or sent someplace else. Some of those concerns are now being assuaged by US-owned companies running open weight models out of US data centers. This makes things feel much more enterprise friendly. US hosting, data residency controls, zero retention options, and policies designed for business use. It's kind of like addressing those concerns. Zooming out, when it comes to model selection, there's more than just price to consider, obviously. It's increasingly which model to choose based on capabilities, where it's hosted, jurisdiction, and which data policy best fits your requirements or your needs. For many teams, open weight plus a trusted US host for US-based companies is a sweet spot, right? They're starting to experiment with it more. Strong capabilities, lower cost, better control over sensitive data. Just how good are some of these open weights models? So just the other week, Moonshot released Kimi K3. It got quite a bit of press. It's priced about the same as Claude Sonnet 5 and about half the cost of OpenAI's GPT 5.6. But how does it actually stack up? Now, you might have some opinions about benchmarks, but the numbers don't lie. So they are, these are benchmarks that span across different problem sets and data sets. And while your mileage may vary depending on the type and size of work that your agent is performing, it's safe to say that a model like Kimi K3 is able to perform very well across benchmark evaluations, like this reasoning and knowledge benchmark evals. The higher the score, the better. And you see on this chart, it's literally being benchmarked against other models that have run on these benchmarks, including Claude's Fable and GPT 5.6. Here we're looking at benchmarks measuring coding capabilities. So you see like a software engineering benchmark tests. So they look like, you'll see that Moonshot K3's model is about half the price compared to the US-based models. It still holds its own when coming to the coding benchmark scores compared to even the most advanced models coming out of Anthropic and OpenAI. There's also some other controversies in terms of how they got so good. I think that you probably can find some posts from some leadership from some of those big flagship companies about their positions on open weight models. These charts came out of Hugging Face, if you want to take a look at them for yourself. So now we've talked about model choice. I just want to talk a bit about some other factors that can lead to hidden costs and risks as you continue to deploy and scale agentic AI at your company. Go step by step here. So when you open up the chat interface in Claude or ChatGPT, you might notice this thing over here, speed, these little knobs you can turn, speed and effort. And basically it allows you to set the reasoning or thinking level. So most of the time you probably ignored that setting, but what does it actually do? The options usually range from low or light to medium to high. The labels are, arbitrary and chosen by the model providers themselves. And it tells the model how much effort should be applied to responding to your prompt or working on it. The typical guidelines are that the more complex the task or the prompt, the higher the reasoning or thinking level should be. So the most noticeable change will modifying this setting would probably be the speed of the response if you're doing things synchronously in chat. Behind the scenes, what it means is that if the reasoning level is set to be very high, the more resources are used or made available when working on your prompt. This not only changes the speed and the response time, but it could also affect the amount of tokens consumed while working on your prompt. You can experiment with this yourself, like, take a not a super trivial binary question and ask, ChatGPT or Claude with different kinds of levels. And you'll notice that it'll take more time to deliberate, maybe even do some things that seem extraneous if you choose a very, very high level. That being said, if you were planning something out very complex, you would probably use that setting. But while working with the API in code, like here I just have like a LangChain agent going through the Barndoor LLM. We have the reasoning effort set to low, like explicitly, and you have to explicitly set that in your API requests. For most models, it's not actually a required parameter. Some they do require it, but for most it's not, and therefore a default is chosen most of the time. And for most, it's not a complete rule like that is applied across the board, but most of them set it to medium. But what if the task at hand that your agent is working on is very simple and doesn't require any deep reasoning or high level of effort, or heck, even a medium level of effort? What if the model you're using has a default reasoning that actually is set high? I think that there's one of the pro versions on OpenAI that it defaults to high. Because that's that's kind of the ethos and the use case is to use this particular model. It's for really, really complex things, so they just kind of defaulted to high. Each model may have a different default setting, and unless you instruct your agent which level to use, you could be adversely affecting the speed of the work that's done, but also just paying for a higher level of effort that wasn't required. So yeah, that's something you really want to keep an eye on, and it's often something that people just overlook because it's not a required parameter to send. Next, I want a quick one here about prompt caching, because it's probably the single biggest lever for cost savings that most teams are not taking advantage of. So when your app or agent sends the model the same context repeatedly, whether it's a system prompt, a reference doc, or information from earlier turns of a growing conversation, prompt caching lets the model reuse what it already read instead of having to pay the full price again, like the full input price. So for example, on GPT 5.6, it costs about $5 per 1 million input tokens. But their price for cached input is only 50 cents per 1 million input tokens on the, again, if it's a cached input. That's a 10x discount on quite possibly the largest line item in most AI spend. For agents, this is not an optional thing. An agent resends its entire growing context on every turn, on every step. So if caching isn't enabled, or if you think it's enabled, but and it's not working properly, the costs can compound quickly. So here's the catch: when caching fails, it fails silently. There's no error, there's no broken output. It doesn't tell you that it failed, it just fails and it just sends you the output. The app quietly just stops saving you money because you're not utilizing the cache, the caching pricing tier. In one real case, an agent ran an LLM and the calls were I think 4 times the normal cost for a 36-hour period. And this was like some hardcore work that was going like solid, minute by minute, just working on a very difficult problem. there was no change or no notification. The cache rate just, it just dropped. And so they were expecting 70 to 80% of a cache hit ratio, but it was actually 10 to 25%. And like literally nobody noticed because there were no errors thrown until the invoice arrived. And it was quite large. So this is the kind of thing that like an LLM gateway, like Barndoor's LLM gateway handles these things automatically. It inserts a correct cache instruction for whichever model is being used by the agent, and it keeps requests stable. And by the way, when it comes to the cache instructions, it's not necessarily the same from model to model or from provider to provider. So you definitely want to check the docs, but this is something that our gateway handles. So a step that could maybe affect caching, like for instance, with our, if you tried to mask or mask some sensitive data before it reaches a model, you need to make sure that you don't just accidentally break the cache in that process. And so like the Barndoor LLM gateway measures the hit rate on every request. So a regression that shows up on the dashboard will show up in minutes and not just on your next AI bill. Tim, one of our co-founders, he just published a blog the other week on this very topic, and he goes into pretty excruciating detail about that case that I mentioned where an agent ran for a 36-hour job and burned a heck of a lot more tokens than they were anticipating. And here's another hiding spot. And this one's about context windows and MCP tools, which can add up tokens to being consumed before actually any work gets done at all. Some people think that this is a completely solved problem, but just to be very clear, it's not. Some AI agents and clients do some job around lazy loading, but I'm just going to explain what the problem is. So every MCP server that your AI connects to, the MCP server will send its full tool catalog to the model. And basically what it's communicating is, here are all the, basically like the methods or the tools that are available to you, model, and just in case you need them, I'm going to add this to basically your context window. So you can refer to it later in the event that a prompt comes up that needs to access any of these tools or where these tools fit the bill. This is how the model's informed, right, about what tools are available. And while it's trying to answer your question, some MCP servers have gargantuan tool sets. The Datadog MCP server, for example, I think it's at around 230 tools. I handle MCP operations at Barndoor. I've seen some MCP servers that have even more. I think there's one later on in the presentation. Atlassian, where I was before I joined Barndoor, they have over 40 tools. If you connect a handful of servers like that, a half a dozen, if you're connecting a whole bunch of your SaaS apps like Priya had, before your agent even starts working on your prompt, it already has loaded hundreds of tool definitions into the context window that it will probably never even use in that conversation. That's not a minor inefficiency. It's a majority of what the model is processing. In production deployments of some agents, some teams they see 80 to 90% of the process or the context window capacity going towards like reviewing tools or storing information about tools that never even get called. If you've been using MCP for a while, you'll probably notice that things have improved, like on Claude. But there was a time in which I could load one or two MCP servers into Claude, and the darn thing would just lock up because the window was completely full. So it's like hiring a consultant and having them read like your entire company directory and history before you even get to ask them one question. When you get past 2 or 3 MCP servers, this is typically starts showing up as a rising cost. You'll get slower responses, or worse, if you just completely overload this thing, maybe the agent will even pick the wrong tool entirely. And in fact, we're kind of seeing this pattern where some SaaS providers that have like multiple MCP servers, we have some customers that might add like multiple instances of the different MCP servers, and you can create some confusion, right? So it's you want to be pretty cautious about not overloading a context window for token bloat, but also just from a tool selection process. So after running MCP, through Barndoor, we have this thing called Tool IQ, and basically it's like an orchestration layer. So instead of seeing, 450 tools across my 5 MCP servers, it doesn't load that entire catalog. An agent that is interfacing with the tool with Tool IQ, they'll only see 8 to 10 tools, and those tools are all designed for very intelligent, dynamic tool selection and execution. So the right tools are surfaced only at the right time that they're needed. So running through the Barndoor, you could probably see a 95% reduction in just processing cost per query relative to loading all of those tools at once. And Tool IQ can scale to, like, we have to hundreds of connected servers. I myself have at least a couple dozen, like real ones. Not if you count like my testing accounts, I have hundreds. But like in the real world, I am when I communicate with AI through my agents do with MCP servers that are running through Barndoor, they are only seeing it only sees 8 to 10 tools, and the right tool just gets surfaced at the right time. All right. So what we're going to talk about here is MCP usage tolls, and rate limits. So this is a semi-spicy one because maybe some companies have charged for API usage, but traditionally it's only those companies that really focus on like consumption-based. And so, for example, like Atlassian has their Rovo MCP server, and depending on the call you're using, if the MCP tool call has to do with inference or AI usage, you're consuming credits. And the credits aren't astronomically expensive, but imagine you have some agentic workflow that is making tool calls to a particular tool that consumes credits. You're not going to see that impact your LLM bill with Anthropic or OpenAI or whoever, but it might hit your Atlassian bill. Similarly, Gong, right? So they have an MCP server that has 3 tools, very powerful tools, but they even have in their documentation, they'll tell you like, hey, by the way, be very specific about what you're asking, because if you ask for something that's too broad, it's going to consume more credits. So hidden cost is not that it's going to hit your main provider bill, but it actually could hit your SaaS bill with any of these providers. On the right, not so much that has to do with cost containment, perhaps, but it's more just about just the limits. So we're starting to see this trend too. So like Figma and Miro both have X amount of calls that can be called per day. With Figma, it's actually across your entire organization based on your plan. With Miro, it's actually on a per user basis, also based on the tier that you're on. So something to look out for. We don't typically, I believe, I would say this is a fairly new pattern, and that you need to be very aware of before you just start having your agent just run willy-nilly against all these MCP servers. So here's another hidden risk about overprivileged tool access, particularly when MCP server changes and new tool changes are made and new tools are introduced. So I have a couple here, like Monday.com. MCP is still fairly new, despite the fact that it's celebrated some birthdays so far. But just look at the deltas here. Just between May and July, we're talking about at least a few dozen new tools were added to the Monday.com MCP server. So what does that mean? And why does that? Why do I mention that it's a potential overprivileged scenario? Because when you authenticate into an MCP server, the most common pattern is that you're going to OAuth with your work credentials, and essentially you're giving this OAuth app, which is an MCP server, access to your account and therefore can perform operations. If new tools are introduced, it doesn't necessarily mean new OAuth scopes are introduced. So therefore, if another tool had some create scopes that were required and you could consented to it, when new MCP tools also are bound by those same scopes, all of a sudden your agent could have access to all of these brand new tools, shiny tools that Monday and other MCP providers are publishing. And that is definitely an overprivileged situation in the sense that you did not explicitly think that I want to give my agent the ability to destroy or create these kinds of resources. So that's something you really need to look out for. So change management is a very big thing that we're focused on at Barndoor because it's very, very dynamic. I mean, to look at post-hog. Post-hog, amazing service. Tools added. These actually might be inaccurate. They might be even higher. They're going tool crazy, and they're not the only ones. Everybody is. They're just adding more capabilities because the more that people, their customers are using it, the more requests are coming in for additional features. So again, imagine for a moment that there's, perhaps some new operations that are introduced that could be, that could be detrimental. And not that your agent is evil, but like, would you just give it tools without knowing that it, without even knowing that those tools had launched? You don't really have visibility on that if you're just giving your tool raw MCP access. So at Barndoor, we provide AI governance that spans across your entire org, including your agents. So Barndoor is a complete governance platform. It was built for agentic AI. Delivers solid controls, visibility, and performance, featuring on the left an LLM gateway, MCP governance gateway on the right, and then data loss prevention in the middle. If you're using AI and deploying agents, but you don't have governance in place, then you already know how difficult it is to fully understand and measure and control your agent's activities. You're probably stitching a whole bunch of different things together to try to get some visibility in terms of like, what is this thing doing and how much is it costing us? And then more importantly, you need to measure the costs related to what your agent is doing. Agents are not scripts and basic, scripted workflows. You're giving the ability for LLMs to perform reasoning, and therefore, have access to the tools and perform things that you might not have anticipated. So you definitely need to keep an eye on things, and I think that having an observability and governance platform is absolutely critical. So for example, like one of the first things I talked about was model selection. So without using an LLM gateway like Barndoor's LLM gateway, you're probably hard coding which models that your apps and your agents are using. And you're probably even hard coding like API keys in there too. So in addition to the lack of agent-specific controls and costs, there are additional risks that you're actually taking on if you have not implemented a proper AI governance layer like Barndoor, like failover, right? In the event that a model provider goes down, I think that we've all seen it happen, right? If you go to the status page of some of the big players, you'll notice that maybe some zones stay up, like the government shard is doing very well, but all of a sudden you'll see like 90% uptime during an incident in which performance is either severely degraded or it's completely down, and basically that means that your agent is now experiencing downtime. If your agent is, if you're doing things very synchronously, okay, you just have to deal with it. But if this is something that you're relying on to do something autonomously, like in Priya, she has this thing, automatically like running and reacting to things that are happening within the business. It just broke your critical path. So not having things like the ability to fail over into another model is a huge risk. So when you do have something in place like Barndoor, your agents and apps can run a lot more smoothly. So even if one model provider experiences downtime or degraded performance, let's say it's really slow and it's just it's overloaded for whatever reason, it doesn't have to be completely down. It just needs to maybe not respond within so many milliseconds or so many seconds, and you want to have it fail over. And it's really easy to configure automatic failover across providers. So it's not just like, GPT 5.6 is down, let's use 5.5. It could be systemic, right? So you might actually have to go to a completely different provider, and you don't have to hard code those things. You do have to now. You have to probably have a failover strategy that's baked into your SDK or your code, but with using a Barndoor, like Barndoor's LLM gateway, instead of hard coding these things, you can set this through configuration settings, like on Barndoor, where you can set things like rate limits, spend budgets, smart routing, timeouts, and failover strategies. And what we're looking at here is the agent profile dashboard on Barndoor. So this is that single pane of glass that everybody dreams about. If you have a real-time view on what every agent in your organization is doing, what it's spending tokens on, because every single call to an LLM, every single tool call to an MCP server, is logged to the agent's profile. So we just unveiled Agent Profile. You can read about it on the Barndoor AI blog. But this is the same kind of, you can give the same kind of access control and to tools, granular access control about what kind of operations can they perform, and even provide even like deeper levels of granular policy control to your agents as well. So like Priya, we're all on this AI journey together. It's becoming increasingly clear that our use of AI and agents is only going to accelerate. So it's imperative that our businesses and our leaders have visibility and control over how AI is being used, and that definitely includes costs. So with Barndoor, we can help you control those costs by making it easy to control and route your agents to the right model for the job that it's doing without having to necessarily hard code those things, and also to have some really advanced smart routing and failover strategies as well. As you deploy more agents, the agents are getting access to more MCP servers and tools. This year was a huge breakout year. I still see a lot of tool deltas and evolutions of MCP servers as I'm in MCP operations. So having rate limits in place to help control runaway costs, maybe that just aren't on your LLM bill, but even on your SaaS bill, is becoming increasingly important. So even like solutions aside, understanding that these, even if a SaaS company is not metering on API usage, they could be metering on LLM usage. The Barndoor Gateway, LLM Gateway, also makes it very easy to put spend ceilings in place at any level. So you can put a spend ceiling on your agent, on individuals if you wanted to, or at the team or group level, or across your entire organization. Having that ability to kind of cap something, you can either set it to warn you, or you can actually set it to block. Can stop any kinds of runaway scenarios and runaway costs. You can be done by request count. It could be done by token count, or even just dollar spend, because the Barndoor LLM Gateway also knows the exact amount of spend that goes through. And when it comes to accessing your enterprise data over MCP, we like Priya, we're all connecting all of our things because they're just the SaaS providers are making it so easy. Barndoor's MCP governance gives you the ability to enforce very granular MCP access controls that your agents will stay in their lane. So even if an upstream provider, MCP server, adds new tools tomorrow, when you have something like the Barndoor MCP gateway in place, because it follows least privilege rules, it's not going to just by default say hey, new tool, let's go ahead, agent, run it. It'll actually deny it, right? And an administrator will have to go in and and set an explicit policy that will allow that agent or that user or that or that client to make that MCP call. So I want to thank you so much for coming. If you'd like to see more, you can book a demo, or if you're just kind of hands-on, you can just go and just try out Barndoor for yourself. You just head over to our website at barndoor.ai.
Thank you, Neil. That was very informative. We have a few questions in the Q&A. We have 6 minutes remaining, so maybe in the last 6 minutes, we can just answer some of the questions.
Sure.
I will share them. So the first question, okay, share. So here's the question from Patrick Rogers. Answers from 3 different models will vary. How does Barndoor help to address this? Referring to previous slide.
Got it. Yeah. So yes, obviously the models will, the answers will vary. The discipline here that you'd want to implement are something called evals, right? So if you actually have a really good set of testing data or testing prompts and resources, similar to the evaluation benchmarks that you can see on Hugging Face or on Open Routers Compare, you want to a real enterprise agentic deployment, all of our very large customers, they're running eval platforms. There are a lot of there's probably one of the most popular open source ones is Phoenix by Arise. So If you want to really start doing like deep evaluations around like prompt performance as it relates to models, you can, you would want to use one of those tools. In terms of Barndoor, I mean, you can actually see the LLM consumption as well as the MCP consumption, both by like just request and spend. But specifically to evals on answers, that's not something that we currently have in our product.
Thank you. Okay, next question. We have a question from Mariam. Let me share. She said, many teams focus on inference costs, but what hidden operational costs tend to be overlooked when AI systems scale? For example, observability, evaluation pipelines, retries, caching, vector databases, or tool orchestration.
Yeah, I mean, so again, we're talking about, particularly in agentic AI, you're not sitting there watching it happen. It just kind of happens. And a lot of these things are, I mean, they're loosely designed for a reason, to actually use the power of inference to do the, to do the thing. That being said, just because you get it gets the job, perceivably gets the job done, where costs could obviously be overlooked is just in the token spend or even the MCP utilization. If you see a session that is absolutely chatty, that maybe took minutes and or just gobs of tokens to accomplish, you're going to probably want to dig into that and see what the problem is. We're able to, we have customers that use our auditing dashboard for that reason. Like they can actually see just like all of a sudden there's like, 500 concurrent requests coming through to an MCP server. Like something's not quite right? Either the agent's gone gone array or something's wrong. So without those kinds of, logging and auditing in place, you'll have zero visibility. So a lot of our customers will actually like export all of their consumption logs import them into some other kind of data warehouse to do some really advanced advanced analytics on it. So you have that ability too. But yeah, back to the previous question, I think that it's a practice that I don't think that many companies are really adept at yet. And that is honestly like running evals.
Thank you. And then we have another question, which is about pricing. Reno wants to know how the Chinese models compare in terms of cost.
Yeah, so I mean, you can head over to Hugging Face or really just head over to any of those, any provider that will show you what the costs are, but they're a fraction of the cost. Kimi K3, the one that I talked about, is probably the most expensive one of the most recent open weights models or the Chinese models, because it's has proven to be pretty capable. But if you look at like the Quen models or the ZAI models, they are probably they're in the cents, right? Like from like 28 cents, 60 cents per 1 million input tokens, whereas you're paying several dollars. So it varies, right? There's a whole bunch of them. I only mentioned a few, DeepSeek, Quen, Moonshot, etc. You can get all that pricing by just heading over to, I think Hugging Face probably has the pricing, or other companies kind of track LLM prices. But so in terms of cost, yeah, there's no question that there are some cost savings to be had by, I would not hesitate if your company allows you to do it. And just if it has anything to do with concerns around like maybe data residency, data retention, and just maybe like, is it a US domiciled company? You can find them, right? There are several companies that provide it. DigitalOcean is one off the top of my head. I think that they have some open weights models, but you can find many that have very explicit terms about that address a lot of the concerns that enterprises are having today when it comes to Chinese as well as open weight models.
Thank you so much. And let's just cover one last question from Patrick. He's asking, is DeepSeek an approved and accepted model worldwide now?
That's a good question. I think it really depends, right? You can find like DeepSeek R1 that is hosted and run, their open weights that are run completely here in the US. And I imagine that there are some enterprises that are taking advantage of that if they're not running it in-house themselves. So I think that, to binary answer would be like, yes-ish. that I think it's accepted that they have very, very capable models. And I think it's just a matter of like what appetite your company has for having to deal with the fact that if you are calling a model provider that is not here in the US, of like what's going to happen to your prompt data and or your tool data that's flowing through. But you can find I believe that with more US providers running Chinese models, we'll see token consumption go up dramatically.
Thank you so much. Thank you so much, Neil, for an amazing session.